composition of the given substance by performing suitable chemical tests. In inorganic qualitative analysis, the process consists of finding the basic radical, cations, and the acidic radical, anion, present in the given salt. We will be using the microscale technique as it requires very small quantity of salts and the apparatus of small capacities. The steps involved in the analysis are as follows. A. Preliminary tests. B. Dry tests for anions. C. Wet tests for anions. Our aim here is to detect one anion from the given salt. To perform this experiment, the apparatus required are 5 ml test tubes with test tube stand, a wooden clip, a bent tube, a small funnel, a 50 ml beaker, a 25 ml conical flask, a tripod stand, wire gauze, a matchbox, and a plastic spoon. Cautions: please keep the test tube slightly tilted towards basin while heating and do not heat for longer time, as sometimes bumping occurs which may cause injury to your eye, face, or neighboring student. Salt 1, Salt 2, Salt 3, Salt 4, Salt 5. Salt 1. Let us first start with a preliminary test. Wash all the apparatus with water. Test 1. Let us find the nature of the salt. Take a pinch of the salt in a small test tube. Add about 1 to 2 ml of water. The salt dissolves in water. Therefore, we know that the salt is crystalline in nature. We can thus infer that water-soluble salt containing ammonium, chloride, bromide, and iodide may be present. Also, sulfate, nitrate may be present. Let us now perform the dry test for anions. Test 1. Action of dilute hydrochloric acid. Take a small amount of the salt in a test tube. Add a few drops of dilute hydrochloric acid. Observe the reaction taking place carefully. We observe a colorless gas evolving with brisk effervescence. Now, fix the rubber cork of the bent tube to this test tube and insert the other end into another test tube containing fresh lime water. Allow the colorless gas to react with lime water for some time. What do you see? We see that lime water is slowly turning milky. This shows that carbonate radical may be present. Test 2. Action of concentrated sulfuric acid. Take a small amount of the salt in a test tube. Add a few drops of concentrated sulfuric acid. Now, heat the test tube gently. Do you observe any brown or violet colored gas? There is no brown or violet colored gas evolved. This shows that chloride, bromide, and iodide radicals are absent. Test 3. Action of manganese dioxide and concentrated sulfuric acid. Take a small amount of the salt in a test tube. Add a pinch of manganese dioxide and few drops of concentrated sulfuric acid. Heat the test tube. There is no brown, violet, or reddish-brown colored gas evolved. This shows that bromide, chloride, and iodide radicals are absent. But there is a colorless gas evolved. Now, hold a wet red litmus paper near the mouth of the test tube and heat it gently. Stop heating. The litmus paper does not become whitish. That is, there is no bleaching of the litmus paper. This shows that chloride radical is absent. Test 4. Copper foil test. Take a small amount of the salt in a test tube. Add a few pieces of copper filings and a few drops of concentrated sulfuric acid. Heat the test tube. Do you see any brown gas evolved? There is no brown gas evolved. This shows that nitrate radical is absent. After performing all the dry tests, we conclude that the probable radical present in the salt is carbonate. Now, we shall prepare the original solution of the salt to perform the wet test. Take a small amount of the salt in a small beaker. Add about 1½ test tube of water to it. Stir the solution. The compound dissolves completely to form a clear, transparent solution. This is called the original solution. Now, we shall perform wet tests using this original solution. Test 1. Take a few drops of the original solution. Add 4 to 5 drops of dilute nitric acid to it. Then add a few drops of silver nitrate. There is a thick curdy white precipitate formed. This indicates that the salt may contain carbonate or any one of the halides, that is, chloride, bromide or iodide. Now, take a part of this precipitate and add 2 drops of dilute nitric acid. Shake well. We see brisk effervescence of carbon dioxide gas. This indicates the presence of carbonate radical. Confirmatory test for carbonate radical. Take a few drops of the original solution. Add 1 drop of phenolphthalein. We can see a pink coloration. This confirms the presence of carbonate radical. Result: acidic radical. CO3, carbonate. Salt 2.